Good morning all. I am Gopika AS, Assistant Professor, Department of Civil Engineering, SNIT ADU, and I am going to share you about a topic from Geotechnical Engineering, and it is Morse-Coulomb's theory. Morse-Coulomb's theory. According to this theory, shear strength depends upon the cohesion between particles on critical plane, angle of internal friction between particles which accounts for interlocking resistance and frictional resistance, and the normal stress on critical or oblique plane which increases with the depth in soil. The important point is that dense sand have greater friction angle. According to Morse-Coulomb's theory, S is equal to C plus sigma n tan phi. It gives the shear strength. Here, C is total cohesion, phi is total friction angle, and sigma n is the total normal stress on critical plane. The figure shows the graphical representation, and in x-axis it is sigma n and in y-axis it is tau, and the inclined line shows the Morse failure envelope, and the point at which this envelope meets the y-axis is called cohesion, and the angle made to the horizontal is called the angle of internal friction. The above theory is found to be incorrect for the condition when water table is present, and hence the above theory is modified and improved by Terzaghi, and this theory is known as modified Morse-Coulomb's theory. According to modified Morse-Coulomb's theory, S is equal to C dash plus sigma n dash tan phi dash. Here C dash is the effective cohesion, phi dash is the effective friction angle, sigma n dash is the effective normal stress on critical plane. The figure shows the modified Morse failure envelope. So let us see what are the limitations of Morse-Coulomb's theory. In Morse failure envelope is approximated to a straight line which is found invalid for over-consolidated soil. The practical result shows that Morse failure envelope in over-consolidated soil is found to be slightly curved. Similarly, the angle is 2D in which sigma 1 and sigma 3 is considered, whereas actual stress condition in soil is 3D in which sigma 2 is sigma 3. Now, let's see what are the different types of shear parameters. Mainly, according to the conditions, the shear parameters are classified as undrained shear parameters and drained shear parameters. If a saturated soil mass is subjected to shear loading and soil is undrained, usually clays, then the total stress should be used and undrained shear parameters can be calculated as the two equations shows for triaxial test and direct shear test. Next one is drained shear parameters. If loading rate is slow and expulsion of pore water completes during loading, then pore pressure will become zero. Then effective stress should be used and drained shear parameters are given as for the first equation is for triaxial and second one is for direct shear. So we discussed about the two different parameters, that is undrained shear parameters and drained shear parameters. The basic shear parameters are cohesion and angle of internal friction, and both are not we can say as a engineering or physical property for soil, because they will vary depending upon the testing conditions and the type of soil and type of loading and the existing conditions in the experiments, and also so I hope you understand this session. Thank you, and we will see in the next video. Thank you.